Alrighty, Ali, let's work on this one. This is the last one for tonight. But, okay, so you have a polynomial right here. So the first thing you want to be able to identify is what's the highest degree of the polynomial. So when you look at here, you have what? X squared. You have x to the first, x to the first, right? So you have this polynomial, if you were to multiply all the x's out, right, it's going to give you, it's a fourth degree polynomial. So it's a fourth degree polynomial, and it's a negative coefficient. So we are looking for a negative coefficient of even degree. And if you remember, an even degree polynomial with negative coefficient is going to look a little bit, actually, let me just do it better. It's going to look maybe, remember like the m, that's the way it's going to look. So it's going to rise to the left and rise to the, I'm sorry. It's going to fall to the left and fall to the right. So that is part A, that is the end behavior. Fall to the left, fall to the right. Now we want to look at all the real zeros. The real zeros are, so let me just go back and, oh, I didn't, this is erase, oh, no, I don't want to do that. So it's, when we look at the real zeros, we have to look at right here. So the real zeros are x equals to 1, x equals to negative 2, and x equals to negative 1. So right here for the second part, we said the zeros with a graph. So all the zeros are 1, 2, negative 1. But you have to be careful about those, okay? So a zero crosses the x-axis only if it has an odd degree, let's say, or odd, actually, let's say odd multiplicity. Odd multiplicity, if I can only spell that. So odd multiplicity, right? This one has an odd multiplicity, and this one has an odd multiplicity. Therefore, the graph crosses the x-axis at those points. So for this question right here, you would write 1 and negative 2. Whenever the multiplicity is even, multiplicity is even, then the graph touches but does not cross the axis. So here we have even multiplicity, so we would have at x equals to negative 1. So at negative 1, it does not cross the x-axis. It touches the x-axis but does not cross it. And finally, well, for part C, we will say the y-intercept. For the y-intercept, we have to set x equal to 0. So then you have, if you have set x equal to 0, you have negative 0 minus 1 is negative 1 times 0 plus 2 is 2 times 0 plus 1 is 1 squared. So you have negative, so you have 1 times 2, so you have positive 2. So the y-intercept would be 2. So 0, 2, that's where the graph is going to cross the y-axis. So how do you plot those points? So the first thing on any graph, you always want to be able to graph the points. So the points you have are negative 1. You also have negative 2. It's not to scale. Okay, this is 1, and this is, well, 2, but you don't have. And we know that it crosses the y-axis at 0, 2, so maybe over here. So this would cross the y-axis. So this is the function not crosses, but intersects at those points right here. So when we look at this, we said that negative 2, right? Negative 2 is a crossing point. A crossing point, since this is a negative coefficient even degree, it must be looking like this at this point. It must be looking like that, because remember that it has to come like this, right? Then we have to say, all right, what happens at negative, hold on. Yeah, so what happens at negative 2? At negative 2, I'm sorry, negative 2, it's the outer point. So this is the point where, remember, the function has to fall to the left. Then we have negative 1. We see that negative 1 is has had an even it's of multiplicity even, multiplicity 2. So therefore we said that it touches the x-axis, but it does not cross the x-axis, right? So it has to, since it must go like, it has to come like this. So your graph is going to look a little bit like this. Then it crosses the, this is the y-intercept, so it must go like that. And then finally for x equals to positive 1, right? Positive 1 is also, it crosses the x-axis, so it has to come down. It has to look like this. So your function will look somewhat like that. So remember that if it's an even multiplicity, so the graph does not cross the x-axis. See, right here, even multiplicity is right here. Wherever we have odd multiplicities, in odd multiplicities, it crosses the x-axis, but you also have to remember what the behavior of the graph, the end behavior of the graph would look like. I hope this helps.